Sanibonani, Dumelani, Abusheni, Molweni. Greetings to you all. Welcome back. Now let us continue with geometric sequence part 2. This time around we'll be using simultaneous equations to solve problems of a geometric sequence when there are terms that are more than one or two terms apart. Okay, now let us do the example. Determine the first three terms of the geometric sequence if the seventh term is 1458, which is 1458, and the fourth term is 54. Okay, now what do we have in this case? Now in this case we've got a sequence like this, empty, and this one is also empty, we do not know. This one is empty. The fourth term is equal to 54. Okay, the fifth term is empty. The sixth term, fourth, fifth, sixth, seventh, it's 1458. Okay, going, etc. Okay, now what is it that we need to do for us to find the to determine the first two terms? We are going to substitute what we know. We are going to substitute what we know on the general term equation. Okay, we first need to determine the first the nth term, the general term, but we are going to substitute what we have on the general term formula. Now the general term formula is Tn is equals to Arn minus 1. Okay, what do we know in this case? We only know that this is the fourth term. This is T4. Okay, T4 is equals to what? 54. So this is going to be 54 is equals to Ar. This is term number 4. N is 4. 4 minus 1. So this is going to be 54 is equals to Ar. 4 minus 1 is 3. So this is going to be our equation 1. Okay, we do the same for this term, the seventh term. So we substitute what we know in our general term formula, Tn, which is equals to Arn minus 1. Now Tn is what? It's 1458, which is equal to Ar. This is term number 7, seventh term. 7, which is n minus 1. So we're going to have 1458 is equal to Ar to the exponent what? Exponent 6. Okay, exponent 6. So now what do? We need to solve this using simultaneous equation, but we have what? Now we have two unknowns, A and R. Okay, so what do we do in this case? This is equation 2. Now we are going to divide. We are going to divide equation 2 by equation 1. Equation 2 by equation 1. Now what is equation 2? Equation 2 is equal to what? Is equal to r to the exponent 6 is equal to 1458. Equation 1, er to the exponent 3 is equal to 54. Okay, so we divide here. Okay, so when we divide a by a, they are going to cancel out. Okay, this is going to cancel out. Okay, and then we are going to have r to the exponent 6 and divide by r to the exponent 3. So when exponents with the same base, when dividing exponents with the same base, the exponents are going to subtract each other. So we are going to just have r 6 minus 3. 6 minus 3 is 3, which is equal to divide by 54. The answer is 27. Here we're going to have 27. Okay, so now we need to solve for what? We need to solve for r. Okay, so now since r cube is equals to 27, we are going to introduce cube root. We are going to introduce cube root on both sides. R cube is going to be equal to 27 square root, therefore a cube root, and we also introduce cube root. This cancels that. Our r is going to be equal to the cube root of what? The cube root of 27. So the cube root of 27 is equal to 3. So the cube root of 27 is equal to 3. Now we have what? Now we have managed to determine our constant ratio. Okay, so how do we get a? Okay, now this is what we're gonna do. We're going to substitute r is equals to 3 into any of these two equations. It can be this one, it can be that one. Okay, let us use this one into equation 1. Okay, so equation 1, that will be 54 is equal to a into r, which is 3 to the exponent 3. Okay, I just substituted r there. Then what are we going to have? 54 is equals to 27 a 27. Okay, and then what are we going to do now? This is 27a. We divide both sides by 27, and also this one by 27. This cancels that. A is going to be equal to 54 divided by 27, 2. A is equal to 2. Okay, so our general term is going to be, therefore Tn is going to be equal to 2. R is 3 n minus 1. Okay, but the question was, what was the question? Determine the first 3 terms. Now since we've got what? Now since we've got a Tn, we can simply get term number 1, term number 2, and term number 3. We can say T1 is equal to 2, 3. We substitute 1 for n for term number 1, 1 minus 1. Then we get our answer there. T2, 2 times 3. For n, we substitute what? We substitute 2 minus 1. We get our answer there. And term number 3, for term number 3, this is going to be 2 times 3 minus 1, and we get our answer there. So this is going to be 2 times 2 multiplied by 3 to the exponent 2 minus 1 minus 1. The answer is 2. And then we substitute what there? We put 2 there. Here 6. We put 3 there. Here we get 18. So our first 3 terms is 2, 6, 18. Okay, so that is how we use our simultaneous equations to determine the general term, of which we later use to find the first 3 terms of the geometric sequence. That will be the end of my lesson. Thank you.